Hello friend, this is Sahil Kamboj and welcome to my YouTube channel Data Science Story. In the previous video, we have learned that when the prediction is the ultimate goal of our business problem, then we should more focus on building the model that is more flexible in nature. And when the inference is our main goal, fundamental goal, then we should go for the less flexible model, or you can say that restrictive model. In today's video, we are going to understand how we can measure the quality of a fit, or we can say how can we measure that the model that we have built is worthy of actually making a good predictions. So today we are going to learn what is MSE, or you can say mean squared error, and what is test and train mean square error, and which is important for us to look into between the train and test MSE, and how we can measure the MSE in Python. So let's get started our video. So what is MSE, or you can say what is mean square error? It is basically a average square difference between the estimate values and the true values, and the formula is here. You can say that yi is the true value and the function of xi is the value that we have predicted based upon our model. And then there is something called train MSE and the test MSE. Okay. So here we have a data set in which the true relationship between the x and the y is given by this black line, and three different models are used. The one is linear model that here is represented by the orange line. Okay, and then there is a more flexible model which is represented by the you can say the blue line here, and then there is again the higher the model that is higher freedom of flexibility is represented by the green line here, that is almost closely follow the data points of our given data set. So in the right hand side of your screen you can see the two lines here, and this graph is between the flexibility of a model and their mean square error, and this is the gray line you are seeing here is the train MSE, train mean square error, and the red line is showing you the MSE that is measured on our test data that the model hasn't seen yet. So our main point that I want you to learn from here or get away from this is that as the flexibility of a model, as we increase the flexibility of a model, the train MSE is going to reduce drastically. Okay, but along with this, the test MSE started to increase from some point. Okay, so this is showing that as we are increase the flexibility of a model, that model is going to overfit the trained data, or you can say here that the green model that is showing here, the green spline line that is showing here is almost closely follows the data points that we have in our data set, and this green line is showing that our model that is showing in green line, it overfits the data so much that its train mean square is almost going to be a 0. But on the other hand, when we are going to use this green model for the unseen data, or say test data, it shows a higher MSE than the model that are less flexible. So the whole point of learning this is that what we are going to achieve here, that we try to find a sweet spot between the flexibility of a model, between the which model we are going to select, and what are their performance for our test data. So we are more concerned for the test mean square error, but not the train mean square error. So we just want to find this sweet spot that I am showing you here. I hope I able to clear you this point. So let's move ahead. So how we will measure the mean square error in the Python? One thing I want to let you understand from here, that mean square error is not the only measure that is used to evaluate a model. There are lots whole different other methods that are used, but this is the basic method and we are following a big series, and this is the one that we are accounted in that book first. Okay, so let's move how we will find a mean square error. For the sake of simplicity, we just use a regression problem and a linear model. Okay, so here are the data points that are showing on the coordinates of x and the y, that is 1 1 2 1 and 3 2 and 4 2 and 5 4. This is the regression lines that fits this data. Okay, these are the points, and these are the predicted values of y from this regression fit. Okay, and what we are going to do here, that we are going to find first the mean square error. That is, first we do the difference between 1 and 0.6, and then we do the difference between this, and then do the difference between these values, and do the square of those values, and then find their mean. So there are two methods that we can use here. That one is numpy. So these are the true values that I am showing you here, and these are the predicted value from the model. Okay, so let's do it. And from numpy is very powerful library of a Python that do the mathematical operations very simply. I will do a tutorial on numpy, but for the sake of this simplicity, just follow along with me. So here I am going to find what I am doing here. Basically, I'm using the numpy and do the square root of that. I'm just using this formula. Okay, I am finding the differences between them. See here, subtract, and then do the square of this whole thing and do the mean of that thing, and we will able to find the MSE. Let's do. Here is the mean square error of this data set, and we can do also this from another library of Python called the sklearn library. And from the sklearn.matrix, just import a mean square error. It's and it will do whole math that we are done just here with the use of numpy with its algorithm, and you will able to find the mean square error of that value. See here, done. So this is all that I have for this video, and we will do the more topics in my coming videos. So please subscribe my YouTube channel and stay tuned. Thank you very much.